Hey, what's going on, guys? Today we're going to talk about evaluating limits graphically. To do so, I'm going to use the graph you see in front of you, but I'm going to start out with a topic you already know about, and that is the end behavior. Specifically, we're going to look at the right and left end behavior. When I'm talking about end behavior, I'm asking the question, what is happening at the ends of the function? Or in other words, what is the limit as x approaches positive infinity of the function? Well, you can see from what you already know, as the graph goes to infinity, the function itself is constantly going up, and it is going to approach infinity. The left end behavior answers the question, what is the limit as x goes to negative infinity, or towards the left, of the function? And from the picture, or the graph, sorry, as I go to the left on the x values, the graph is decreasing lower and lower and lower, which is approaching negative infinity. So rather than looking at end behaviors, I can also look at specific points. For example, what happens as the limit as x approaches the value of 3? Well, it appears from my graph that as my x values get closer and closer to 3, the graph is slowly approaching 4. Now granted, this is just an estimation because we're doing this graphically. It's still pretty clear cut that the graph is pretty much getting close to 4, maybe 4.1 depending on how you want to call it. Now, in order for a limit to exist at a specific point, the limit must be the same as we approach that point from the left and right. So from the left, the limit as x approaches 3, notice the notation here. 3 from the left-hand side, the negative denoting that we're coming from the left, meaning I'm at 1 at an x value of 1, an x value of 2, 2.5, 2.9, and when I get to 3 from the left, the limit of f of x equals 4. I must also approach the value of x equals 3 from the right. So I would denote that the limit as x approaches 3 from the right, the notation again, a plus sign to the right of the 3. So I'm going to start coming down the graph. I'm at an x value of 4, an x value at 3.5, an x value of 3.1, and you can see again I'm still getting closer and closer to f of x equals 4. So since the limit as x approaches 3 from the left equals 4, and the limit as x approaches 3 from the right equals 4, I can say that indeed the limit does exist where the limit as x approaches 3 of f of x equals 4. In order for a limit to exist at a specific value, the left-hand limit and the right-hand limit must have the same answer. In this case, f of x equals 4. In another example, let's look at the limit as x approaches 0. But before I do that, I must see what the limit of f of x is as x approaches 0 from the left, the negative sign. So I'm going to come up the graph until I get to an x value of 0. There's an x value of negative 1/2. And when I get to 0, I'm going to call it, I don't know, let's say 1/2 just for argument's sake. The limit as x goes to 0 from the plus right-hand side, we're going to be getting closer and closer, starting from 1, 1/2, 0.1, and 0 from the right-hand side is 1/2 as well. So now I can make the statement, the limit as x goes to 0, f of x equals 1/2. The left-hand limit exists at 1/2. The right-hand limit exists at 1/2. Therefore, the limit as x approaches 0 equals 1/2. Now, an interesting point to look at a limit is where we have this jump at x equals 1. Let's find the limit as x approaches 1. Well, in order to do that, I first have to look at the limit as x approaches 1 from the left-hand side. So I'm coming up the graph until I get to a positive 1, and we can say that has a limit of 1 from the left. from the right, when I'm coming down on the upper part portion of the graph, the limit as x comes to 1 from the right-hand side is roughly at 3. Well, these two limits do not agree. The left-hand limit is not the same as the right-hand limit. So we would say the limit as x goes to 1 does not exist. Let's look at a graph that's a little bit more involved. Feel free to hit pause if you need a second here to sketch the graph in your notes. First, let's look at the limit as x goes to 0 from the left-hand side. I'm working my way up, getting closer and closer to 0 from the left, and it looks like roughly the graph is going to cross through at an x, or an f of x value of -1/2. The limit as x goes to 0 from the right-hand side, I'm coming down the middle portion of the graph, and I'm getting closer and closer to 0 from the right, and it's going to agree with the same point, -1/2. Well, since the left-hand limit is the same as the right-hand limit, we can say that the limit as x approaches 0 of f of x equals 1/2. Let's look at some more of these interesting points here. Specifically, the limit as x approaches 1. The limit as x approaches 1 from the left-hand side. I'm looking at the x values, and I'm getting close to 1, and here I am. But if you notice, I have a hole here, but nonetheless, I'm still approaching a y value, or f of x value, of 0. The limit as x approaches 1 from the right-hand side, I still approach the hole, but I'm getting closer and closer to a value of 0. Well, since the limit as x approaches 1 from the left equals the limit as x approaches 1 from the right, we can say that the limit as x approaches 1 is equal to 0. Interestingly enough, though, the function itself, the f of 1, does not equal 0. The f of 1, the function evaluated at 1, has a value of -1. The function evaluated at 1 does not have to agree with the limit at 1, in this case because of the hole. Let's see what's happening at x equals -2. As x approaches -2 from the left, I have an asymptote. The graph is going to continually go up towards infinity, but you know I cannot get there. So we say the limit does not exist. The limit as x approaches -2 from the right is going to follow along the asymptote again, but this time towards -infinity. Still, we cannot get there, and it does not exist. Well, the left-hand limit does not exist. The right hand does not exist. They are approaching two different points. We would say the limit as x approaches -2 does not exist, and that's because of the vertical asymptote. Let's take a second and look at what's happening at the other asymptote, +2. The limit as x approaches +2 from the left, it is an asymptote. It's going up towards +infinity, but I can't get there. The limit does not exist. The limit as x approaches 2 from the right-hand side still goes towards +infinity. I cannot get there. It does not exist. So we say the limit, even though they are in agreement with each other, but I cannot get to either place. The limit as x approaches 2, it goes towards infinity, but we still denote that it does not exist. In the previous example, the limit was going to +infinity and -infinity. We simply say does not exist. And here I do make a slight exception. I say, hey, it's going towards infinity, but we all know it does not exist. So just a few more items. The function evaluated at 0, the f of 0, equals roughly -1/2. The function evaluated at -2, well, now I'm on the asymptote, does not exist. And the function evaluated at +1, which I already mentioned, equals -1. Let me do a few examples from the following function. a little bit more involved and try to just hit you with a few more concepts along the way. Again, feel free to hit pause to copy the question itself at any point in time. Feel free to rewind if you miss anything I said. For this function, I'm first interested in the limit as x approaches 0. Well, in order to answer that question, I have to come into 0 from the left, and then come into 0 from the right. The limit as x approaches 0 from the left, I would be down on this portion of the graph. I'm at -1. I'm riding along the horizontal portion of the graph, getting closer and closer to 0 from the left, and I hit a value of -1. From the right, I'm on this portion of the horizontal graph, working my way from the right towards my left, and I'm getting closer and closer and closer. Even though there's a hole here, I'm still getting closer and closer to a value of 0. Well, the left-hand limit is not the same as the right-hand limit. We would say that the limit does not exist. In similar fashion, the limit as x approaches -2. I'm at an x value of -2, and I'm going to come at it from the left. I'm on the curve at the bottom. I'm approaching it from the left, and I'm getting closer and closer to a value of roughly -3. The limit as x approaches -2 from the right, I'm on the horizontal portion, approaching it from the right, has a limit of -2. The left-hand limit does not equal the right-hand limit. I would say the limit as x approaches -2 of f of x does not exist. A few more odds and ends on this one. The function evaluated at -2 would have a value, f of -2. I plug in. There's a hole there. I jump down to the bottom portion where the curve is. I would have that f of -2 equals -3. The function evaluated at 0, there is a hole there. I would jump down to where the graph does exist. Would have a value of -1. Notice the function exists at -2, even though the limit does not. That pretty much sums it up on evaluating limits graphically. We will continue to evaluate limits by hand, both using a calculator and allowing you to plug in certain situations. I will give you some properties of limits, and we'll keep moving on.